Hey everyone, get ready to ignite the AI revolution. I'm Praveen and we are exploring Neam, the language for agentic intelligence. Welcome to the future of intelligent systems. Join us as we unleash Neam's power and shape the AI frontier. Subscribe and be part of the spark. Look at this line of code. Data flows in from the left, gets filtered, doubled, sorted, and trimmed all in one readable left to right expression. No nested function calls, no temporary variables, no reading inside out. This is the pipe operator. And once you learn it, you will never want to write code without it. Welcome to Season 2. Season 2 starts with the building blocks. In Neam, you declare variables with two keywords, let and const. Let creates a mutable variable. You can reassign it later. Const creates an immutable binding. Once set, it never changes. No var, no auto, no colon equals. Just let and const. And here's what's beautiful. Neam has full type inference. You write let name equals quote Neam, and the compiler knows it's a string. You write let count equals 42, and it knows it's a number. You can add explicit type annotations if you want clarity, but the compiler doesn't need them. This means less typing, but full type safety at compile time. Neam gives you 13 core types, and they're divided into three tiers. The primitives, number, which unifies integers and floats into a single type, so you never worry about int versus float conversions. String, UTF-8, immutable, with all the methods we learned in video 3. Boolean, true and false. And nil, the explicit absence of a value. The collections, list for ordered sequences that can hold mixed types. Map for key value pairs. Tuple for fixed size mixed type groups. Set for unique values. And range for numeric sequences. 0.10 gives you 0 through 9. 0.. equals 10 includes 10. And the advanced types, option for null safe values. We'll go deep on this in video 8. Typed array for vectorized math operations. Record for lightweight name structs. And table for SQL like tabular data. 13 types. Each one purpose built. Now here's something that will trip you up if you come from Python or JavaScript. In Neam, only TWO values are falsy, false and nil. That's it. 0 is truthy. Empty string is truthy. Empty list is truthy. This is a deliberate design choice. Neam says, if you want to check whether something is empty, check explicitly with .len equals 0. No more bugs from accidentally treating 0 as false when it's a legitimate value. Two falsy values. Remember that. Neam's operators are mostly familiar, arithmetic, comparison, logical. Notice, Neam uses the words and, or, not instead of symbols. The N operator is incredibly useful. Check membership in lists, ranges, even maps. But here's the feature that will make data people smile, broadcasting. When you multiply a list by a scalar, the operation applies to every element. Prices times 1.1 gives you every price with 10% tax. No loops. No map calls, just direct readable math on collections. This is borrowed from NumPy's philosophy, but built into the language. And now, the star of this video, the pipe operator, two characters that will change how you think about code. Here's how it works. The result on the left side of the pipe gets passed as the first argument to the function on the right side. That's it. But the impact is enormous. Look at the top line, nested function calls. You have to read it inside out. Map first, then filter, then sort, then take. Your eyes jump all over the place. Now look at the piped version. Start with the list. Pipe it to map. Square every number. Pipe to filter. Keep values greater than 5. Pipe to sort. Pipe to take 2. You read it left to right, top to bottom, exactly in the order operations happen. This is how your brain thinks about data transformation. The pipe operator makes code match your thinking. Pipes work with everything. String processing, take messy input, trim white space, lowercase it, capitalize. Data analysis, filter scores, sort them, compute the mean, one pipeline, one expression. You can even nest pipes. Here we are piping each name through capitalize inside a map, then filtering and joining. The pipe operator isn't just syntax sugar, it's a way of thinking. And when we get to agents in season 3, you'll pipe AI responses through validation, parsing, and formatting, all in a single readable chain. Destructuring lets you unpack collections into individual variables in one line. Lists use square brackets. The first element goes to the first variable, second to second, and so on. Use underscore to skip values you don't need. Tuples use parentheses. Maps use key colon variable syntax, and the spread operator, 3 dots, captures the rest of a collection. Head gets the first element, ... rest gets everything else as a new list. You can also use spread to build new lists by combining existing ones. Destructuring eliminates dozens of lines of index-based access. One line, all the values you need. Slicing works like Python but with an important addition, step values. Start colon n gives you a range. Omit start for the beginning, omit end for the rest. Add a third value for step. 0 colon 10 colon 2 gives you every other element. Double colon 3 gives every third. And colon colon negative 1 reverses the entire list. For type conversion, Neam gives you 4 functions: str for strings, num for numbers, int for integers that truncate decimals, and bool for booleans. And watch out, bool of 0 returns true. Remember, only false and nil are falsy in Neam. Let's put everything together in one program. We have student grades as a list of tuples. First pipeline, filter for scores 85 and above, format each as a string, sort alphabetically, join with new lines, honor roll, done. Second, extract just the scores using map with underscore to ignore names, then compute average, max, and min. Third, broadcasting. Add 5 to every score in one expression. And finally, destructuring. Sort descending and unpack the top 3 into named variables with spread capturing the rest. This is 13 lines of data processing. In Python, this would be 30 or more. In Neam, every line reads like a sentence. That's the power of pipes, broadcasting, and destructuring working together. Challenge time. Build a pipe operator showcase. Start with 10 numbers. Create a single pipe chain that filters odd numbers, doubles the rest, sorts descending, and takes the top 3. Then destructure those 3 into named variables. Use broadcasting to add 100 to the original list. And for the bonus, build a string cleaning pipeline using pipes. Share your most elegant pipe chain in the comments. I want to see how creative you can get with this operator. In the next video, we take the pipe operator and supercharge it with functions. Named functions, anonymous functions, higher order functions like map, filter, and fold. You'll learn how pipes and functions together create a style of programming that's concise, readable, and incredibly powerful. The building blocks are set. Now we learn to compose them. See you in video 5.